The wreck lay folded against an English hedge near Exeter, smoke still curling from twisted metal that refused to fully burn. The grass beneath it scorched black, the surrounding trees stripped of leaves by cannon fire. RAF ground crew approached slowly, boots crunching through debris. They had watched it fall, trailing flames like a dying comet, yet the pilot had walked away with barely a scratch. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Squadron Leader Peter Matthews knelt beside the fuselage, running his fingers across holes punched clean through the cowling. 20mm hits, direct strikes, enough firepower to shred a Spitfire's Merlin engine into scrap. But this machine, this brutish German fighter with its wide nose and peculiar radial engine, had absorbed the punishment and kept flying long enough for its pilot to reach friendly territory. He tapped the engine cowling with his knuckles. Solid. Dense. A fortress of metal cylinders arranged in a circle, each one a separate fortress guarding the aircraft's heart. Matthews had flown fighters since 1939. He knew engines. Liquid-cooled Merlins with their glycol coolant flowing through delicate pipes. One puncture, and the system bled out, the temperature climbing, the seizure inevitable. But this was different. This was the Fw190, and it had just changed everything the RAF thought they knew about air combat. The date was September 21st, 1941. Over the skies of France, British pilots had begun encountering a new adversary. At first, intelligence officers dismissed the reports as misidentifications, perhaps captured French Curtiss fighters pressed into German service. But the accounts kept coming. A radial-engined fighter that could outrun, outclimb, and outdive every Spitfire in Fighter Command's arsenal. The Germans called it the Würger, the butcher bird, a name borrowed from a species of shrike known for impaling its prey on thorns, letting them hang as trophies. RAF pilots, initially skeptical, soon understood why. The machine didn't just defeat you, it dominated you. And then it survived what should have killed it. Wing Commander James Johnson remembered his first encounter vividly. "We thought we had them," he would later write in his combat log. "3 of us on Fw190, converging from different angles. I saw my rounds striking home, saw the smoke, saw pieces flying off. And then the bloody thing just rolled over and dove away like nothing had happened. It was as if we'd been firing blanks. But they hadn't been firing blanks. They had been shooting at an engine designed not by artists dreaming of speed, but by engineers obsessed with survival." The BMW 801 Radial, 14 cylinders arranged in 2 rows, each cylinder a separate block of cast aluminum fin surrounded by cooling fins. Air-cooled, self-contained, redundant. If you destroyed 1 cylinder, 13 remained. If you punctured the oil cooler, the engine could run dry for minutes before seizing. If you riddled the cowling with holes, you only improved the airflow. The revelation came in pieces, each combat report adding another fragment to a picture Fighter Command didn't want to see. On October 14th, 1941, Squadron Leader Alan Deer engaged what he thought was an easy target, a lone German fighter limping home with visible battle damage. He closed to 200 yards and opened fire with his Spitfire's 8 Browning machine guns. The streams of .303 caliber rounds stitched across the 190's fuselage. The German fighter shuddered but didn't break. Deer switched to a head-on pass, cannon fire this time, 20mm shells. He watched them strike the engine, saw metal fragments spin away into the slipstream. The 190's propeller kept turning. It banked hard right, using a roll rate that left Deer's Spitfire floundering, and disappeared into a cloud bank before he could reposition. That evening, Deer stood in the intelligence briefing room pointing at silhouettes pinned to the wall. "It's the engine," he said. "That radial soaks up damage like a sponge. You can hit it repeatedly, and it just keeps running." The intelligence officer frowned. "All engines can be destroyed, Squadron Leader." "Not this one," Deer replied. "Not easily." Across the channel, Luftwaffe pilots were learning the same lesson from the opposite perspective. Lieutenant Josef Priller of Jagdgeschwader 26 described his first sortie in the 190 as a revelation. The Messerschmitt 109 was a thoroughbred, he wrote. Fast, agile, beautiful to fly, but fragile. One good burst in the radiator and you were gliding home, praying to make the coast. The 190 was different. It was a workhorse, crude, even. But you felt safe inside it. That engine out front was a shield. The engineering philosophy behind this shield began in the late 1930s, when Focke-Wulf's chief designer, Kurt Tank, made a controversial decision. While the rest of Europe pursued sleek inline engines for their fighters, prioritizing speed and aerodynamic cleanliness, Tank chose bulk over beauty. He selected a radial engine, the type usually reserved for bombers and transport aircraft, machines that valued reliability over performance. His reasoning was cold, practical, born from battlefield reality. Radial engines had no coolant system to puncture, no radiators to fail, no glycol lines snaking through the fuselage waiting for a single unlucky round to drain them dry. The cylinders sat exposed to the airstream, each one cooled independently by a fan-driven torrent of air. Damage to one cylinder barely affected the others. The engine could lose entire chunks of itself and still produce power. Tank's team designed the cowling to be as tight as possible. Using a 12-bladed cooling fan, mounted directly behind the propeller to force air through a narrow gap between the cylinders and the fuselage. The system consumed power, about 70 horsepower at low altitude just to drive the fan, but the payoff was survivability. And in a war where trained pilots were becoming more valuable than machines, survivability mattered more than raw speed. The BMW 801 itself was a marvel of engineering pragmatism. Displacing 41.8 litres across 14 cylinders, it produced 1,700 horsepower in its D-model configuration. More importantly, it did so reliably. The engine featured an early form of electronic management, the Kommandogerät, a mechanical computer that automatically adjusted fuel mixture, propeller pitch, boost pressure, and ignition timing. Pilots controlled only the throttle. Everything else was handled by the system, reducing workload and preventing catastrophic pilot errors. But the true genius lay in the engine's modular design. Each cylinder head could be removed and replaced in the field with basic tools. Mechanics didn't need specialized training or factory equipment. A damaged cylinder could be swapped in under an hour. The engine's construction used simple, robust components that could be manufactured in workshops across Germany and occupied Europe. Mass production wasn't hindered by the need for precision machining or exotic alloys. The 801 was designed to be built by the thousands, maintained by the hundreds, and destroyed only with great difficulty. By early 1942, the 190's reputation had solidified. RAF pilots over France flew with heightened caution. They avoided head-on attacks where the radial engine acted as armor for the pilot. They learned to aim for the wings, the tail, the cockpit, anywhere but that implacable wall of spinning metal at the front. But even careful tactics couldn't fully negate the advantage. On February 12, 1942, the German battleships Scharnhorst and Gneisenau made their famous Channel dash, sailing from Brest through the English Channel in broad daylight. The Royal Air Force threw everything available at them, waves of bombers and torpedo aircraft. Covering them were Spitfires. Hunting the Spitfires were 190s. The results were lopsided. Fighter Command lost 42 aircraft that day. The Luftwaffe lost 17, most of them bombers. The 190s were nearly untouchable. Wing Commander Robert Stanford Tuck, a veteran ace with nearly 30 victories, was shot down and captured during that engagement. He later described the experience in a prisoner of war camp interview. "I put everything I had into one of those Focke-Wulfs. Saw my rounds hitting all along the fuselage. The pilot didn't even flinch. He just turned into me, and his cannons did what mine couldn't. My Merlin took one hit in the coolant system, and that was that. 10 minutes later I was in the water." The psychological impact was profound. For 2 years, RAF pilots had believed in the superiority of British engineering. The Spitfire was a symbol, not just of air power, but of ingenuity and fighting spirit. Now, suddenly, they were flying an outdated machine against an adversary that seemed to shrug off battle damage through sheer brute engineering. Morale didn't collapse, but it strained. Pilots requested transfers. Others pushed for the development of new fighters. The pressure mounted on the Air Ministry to respond. The answer came partly through espionage, partly through extraordinary luck. British intelligence had been desperate to examine an intact Fw190. Plans were drawn up for commando raids on French airfields. One scheme involved a German-speaking RAF pilot flying a captured Messerschmitt into France, landing at a Luftwaffe base, demanding a replacement aircraft in fluent German, and taking off in a stolen Fw190. It was desperate. It was unlikely. And it proved unnecessary. On the afternoon of June 23, 1942, Oberleutnant Armin Faber of Jagdgeschwader II climbed into his Focke-Wulf 190A3 for what should have been a routine combat patrol. His unit was scrambled to intercept British Boston bombers returning from a raid, escorted by Czechoslovak manned Spitfire squadrons. The fight developed over the English Channel, a swirling melee of tracers and smoke trails. Faber engaged a Spitfire flown by Sergeant František Treitnar. The dogfight was intense, high-speed maneuvers that left both pilots disoriented. Faber, with only one cannon still functioning, pulled an Immelmann turn into the sun and fired a desperate head-on burst. Treitnar's Spitfire disintegrated. The Czech pilot bailed out with a shrapnel wound in his arm and a broken leg, landing near the village of Black Dog in Devon. But the maneuver had consequences. Faber, low on fuel and thoroughly disoriented, no longer knew which direction it was home. He saw water below, assumed it was the English Channel, and turned north, thinking he was heading toward France. In reality, he was flying over the Bristol Channel toward Wales. When his fuel gauge touched empty, he spotted an airfield and descended, performing a victory roll to celebrate his kill. The airfield was RAF Pembrey, a training station in South Wales. The men on the ground stood frozen in disbelief as a German fighter, complete with Luftwaffe markings, rolled its wings and touched down on British soil. Sergeant Jeffreys, the duty pilot, grabbed the only weapon available, a flare gun, and sprinted toward the taxiing aircraft. He leaped onto the wing as Faber opened his canopy and shoved the very pistol into the stunned pilot's face. Faber's expression, witnesses later said, was one of pure horror. He realized his mistake too late. In his exhaustion and confusion, he had delivered to the British the very thing they had been scheming to steal. An intact, undamaged, fully operational Focke-Wulf 190, complete with ammunition, fuel system diagrams, and the mysterious BMW 801 engine. The fighter was immediately transported by truck, piece by piece, to the Royal Aircraft Establishment at Farnborough. There, under heavy guard, British engineers began the most important examination of the war. They measured every dimension, weighed every component, photographed every rivet. On July 3, 1942, test pilot Wing Commander Hugh Wilson fired up the BMW Radial for the first time on British soil. The sound was different from a Merlin, deeper, rougher, a mechanical growl rather than a high-pitched howl. Wilson taxied carefully, feeling the wide-track landing gear that made the Fw190 so stable on rough ground. He advanced the throttle and lifted off, climbing into the summer sky over Hampshire. What he discovered over the next 9 hours of flight testing would reshape RAF tactics and accelerate the development of new British fighters. The Fw190 was faster than the Spitfire Mark V at all altitudes. It climbed better. It dove better. Its roll rate was extraordinary, the best of any fighter in the war. In a turning fight, the Spitfire could eventually outturn it, but only if the German pilot chose to remain in the turn. With its superior roll and dive performance, the Fw190 could simply flick into an opposite turn, dive away, and disengage at will. Most troubling was the armament. 4 20mm cannons and 2 machine guns. The firepower was devastating. A single burst could destroy a bomber or shred a fighter. British pilots flying Spitfires with 8 machine guns felt outgunned and outclassed. But it was the engine that captivated the engineers. They removed the cowling and stood in silence, studying the BMW 801's architecture. Chief Engineer Ronald Bishop circled the installation, notebook in hand, sketching the cooling fan arrangement, the oil cooler placement, the simplicity of the cylinder attachment points. "It's not elegant," he finally said, "but it's brilliant." A junior technician pointed to the armoured oil cooler ring, positioned directly behind the fan. "This plating weighs over 70 kilograms. Why would they add that much weight?" Bishop tapped it with his knuckle. "Because they expect to be shot at from the front. Head-on attacks, defensive fire from bombers. This armour protects the cooling system without adding external drag. Its vulnerable positioning turned into protection through sheer mass." They test-fired machine guns at a spare BMW cylinder head, measuring penetration and fragmentation. The results were sobering. Unless you hit the cylinder dead-on with cannon fire, it absorbed machine gun rounds with minimal damage. The fins helped dissipate impact energy. The cast aluminum was thick enough to stop most pistol-caliber rounds entirely, and with 14 cylinders, losing one or two barely degraded performance. One engineer wrote in his report, "The German approach is fundamentally different from ours. We build for performance and accept fragility as a trade-off. They build for endurance and accept bulk as necessary. In a war of attrition, their philosophy may prove superior." The Air Fighting Development Unit at RAF Duxford received the captured 190 in mid-July 1942. There, it was pitted against every Allied fighter available, including the newly arrived Spitfire Mark 9, with its two-stage supercharged Merlin 61 engine. The comparative trials lasted weeks, each sortie meticulously documented, each maneuver analysed frame by frame through gun camera footage. Flight Lieutenant Raymond Lallemant flew both aircraft during the evaluation. His report, stamped secret and circulated only among senior officers, contained a single line that summarised the strategic problem facing fighter command. Against the Mark 5, the 190 dictates every engagement. Against the Mark 9, we achieve parity. But parity means they choose whether to fight or flee, and we cannot force the issue. The trials confirmed what combat pilots already knew. In a head-on attack, the 190's radial engine absorbed punishment that would cripple a Spitfire. In a diving attack from above, the 190 could simply roll inverted and dive away faster than any pursuer. In a turning fight, if the German pilot felt threatened, he could flick roll into an opposite turn so violently that Spitfire pilots couldn't follow without greying out from G-forces. But the evaluation also revealed weaknesses. Above 20,000 feet, the BMW 801 single-stage supercharger began to struggle. Power dropped off noticeably. The 190 became sluggish, less responsive. At 25,000 feet and higher, Spitfires could outclimb and outrun it. The vulnerability was real, but it was also limited. Most combat over Europe occurred below 15,000 feet, where the combat 190 remained dominant. The psychological dimension of the radial engine's resilience became apparent during mock combat exercises. British test pilots, knowing they were flying against a friendly aircraft with no ammunition, still hesitated during head-on passes. The visual of that massive radial engine coming straight at you, its wide spinner and broad cowling filling your windscreen, triggered instinctive caution. Pilots would break off early, giving the 190 pilot the advantage. Squadron leader Hugh Wilson noted in his diary, "Flying the 190 feels like sitting behind a bank vault. You know intellectually that you're vulnerable from the sides and rear, but psychologically, that engine makes you feel invincible. I cannot imagine what it must be like for our lads to face this thing in combat, knowing their own engines will die from a single unlucky round." Back in France, Luftwaffe pilots were writing their own assessments. Hauptmann Johannes Seifert, of Jagdgeschwader 26, kept a detailed logbook of combat damage his 190 sustained over 6 months of operations. The entries read like a testament to engineering resilience. August 4, 1942. Multiple machine gun strikes to engine cowling. 2 cylinders hold. Oil pressure dropped but remained operational. Returned to base. Repairs completed in 4 hours. August 19th, 1942. Engaged 8 Spitfires during Dieppe operation. Took 20mm hit to number 5 cylinder. Engine vibration increased, but power output acceptable. Claimed 2 Spitfires destroyed before breaking off. Landed safely. Cylinder replaced overnight. September 2nd, 1942. Head-on attack against Boston bomber. Defensive fire struck oil cooler and forward cowling. Temperature rose but stayed below critical. Completed mission. Minor repairs required. The pattern was clear. The BMW 801 could absorb battle damage that would doom other fighters. But the resilience came at a cost. The engine was heavy, nearly 700 kilograms fully dressed. The cooling fan consumed power at all altitudes. The wide frontal area created drag that limited top speed compared to sleeker inline engine designs. And at high altitude, where thin air reduced cooling efficiency and supercharger performance, the 190 struggled. German engineers knew these limitations. They had been working since 1941 on high-altitude variants, the B and C models with turbocharged engines and pressurized cockpits. But development was slow, hampered by material shortages and bombing raids on BMW's factories. The standard A model 190, with its reliable but altitude-limited BMW 801, remained the Luftwaffe's backbone through 1943. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Meanwhile, across Atlantic, American engineers studied intelligence reports about the 190 with intense interest. The U.S. Army Air Forces was preparing to join the daylight bombing campaign over Europe, and they needed fighters capable of escorting bombers to targets deep in Germany. The Republic P-47 Thunderbolt, powered by a massive Pratt & Whitney R2 800 Radial engine, was entering service. Its designers had faced similar challenges to Kurt Tank: how to make a radial engine fighter competitive with inline engine adversaries. When fragments of intelligence about the BMW 801's combat resilience reached Republic's engineering team, they felt vindicated. Their own approach, using thick armor plate around the cockpit and a massive radial engine as a frontal shield, mirrored German thinking. The P-47 would prove even more survivable than the 190. Its larger engine and heavier construction absorbing damage that would cripple smaller fighters. But in the skies over France during the summer of 1942, the 190 reigned. The Dieppe raid on August 19th became a demonstration of its dominance. Operation Jubilee was intended to test amphibious assault tactics, but it turned into a bloodbath on the beaches and in the air above them. Fighter Command flew 71 squadrons in support, over 100 sorties. The Luftwaffe, with just 2 fighter wings, JG-2 and JG-26, met them with approximately 200 sorties. The day's air combat resulted in 96 RAF aircraft destroyed or damaged beyond repair. German losses totaled 48, mostly bombers and reconnaissance aircraft. The 190s of JG-2 and 26 were nearly untouchable, their radial engines absorbing hits that would have been fatal to Messerschmitt 109s. British pilots returned shaken, reporting 190s that kept fighting despite visible battle damage, despite smoke trailing from punctured cowlings, despite cylinders blown apart by cannon fire. Wing Commander Johnny Johnson, who would later become the RAF's highest-scoring ace, flew that day in a Spitfire Mark V. He engaged a 190 at close range, fired a long burst that he was certain had struck home, and watched in frustration as the German fighter simply rolled away and dove for the deck. "I saw pieces flying off," he wrote. "I saw smoke, but the bloody thing just kept going. It was like shooting at a tank." That evening, as exhausted pilots filled out combat reports, the truth became undeniable. The Spitfire Mark V was obsolete. The 190 had fundamentally altered the balance of air power over Europe. Fighter Command needed new fighters, and it needed them immediately. The response was already in motion. The Spitfire Mark IX, with its more powerful Merlin 61 engine, had entered squadron service in July. By autumn, enough Mark 9s were operational to challenge the 190 on more equal terms. The performance gap closed. British pilots regained confidence. But the Mark 9 was essentially an emergency adaptation, a Mark 5 airframe with a more powerful engine grafted in. It restored parity but didn't establish superiority. More radical solutions were in development. The Hawker Typhoon, powered by a massive Napier Sabre inline engine, was entering service as a low-altitude interceptor and ground attack aircraft. Its thick wings and heavy construction gave it survivability, approaching the 190s. The Tempest, an improved Typhoon with refined aerodynamics, would follow. Both designs showed British engineers learning from their adversary, prioritizing pilot protection and structural resilience alongside performance. But the clearest evidence that the 190 had changed British thinking came in small details scattered across new fighter designs. Increased armour plate around cockpits, redundant fuel systems, self-sealing tanks mounted in protected positions, cooling systems with backup capacity. These weren't revolutionary changes, but they represented a philosophical shift. British fighters were no longer designed purely for performance. They were designed to bring pilots home. German pilots, meanwhile, were developing tactics to maximize the 190's strengths. They avoided prolonged turning fights where Spitfires held the advantage. Instead, they used superior speed and dive performance to engage on their terms, striking fast and disengaging before the enemy could respond. The vertical fight became the 190's domain, yo-yoing up and down through altitude bands, using energy management rather than sustained maneuverability. Oberleutnant Otto Stamberger described the approach in a post-war interview. In the Messerschmitt, you fought with elegance. In the 190, you fought with brutality. You came in fast, hit hard, and left before they could react. If someone got on your tail, you didn't try to outturn them. You rolled hard, dove, and used your speed to escape. The engine gave you confidence to be aggressive. You knew it could take hits and keep running. That confidence was earned through experience. Stamberger's own aircraft took major battle damage on 3 separate occasions. Once, a Spitfire's cannon fire destroyed 2 cylinders on the starboard side of his BMW 801. The engine vibrated violently, oil temperature climbed, but power remained sufficient for flight. He nursed the damaged fighter back to his airfield in Belgium, landed safely, and was flying again the next morning after mechanics replaced the ruined cylinders. You developed a relationship with that engine, he said. You trusted it. I never felt that way about the Messerschmitt. Its engine was powerful but fragile. One coolant leak and you were gliding. The 190's Radial was crude, loud. It drank fuel and made the aircraft nose-heavy, but it forgave mistakes and absorbed punishment. In war, forgiveness matters more than perfection. The tactical lessons flowed both ways. As German pilots learned to exploit the 190's strengths, British pilots learned to avoid its advantages. They engaged at high altitude when possible, where the BMW 801's performance degraded. They used numerical superiority to force the Germans into defensive maneuvers, negating the 190's ability to dictate engagement terms. They aimed for wings and tail surfaces rather than the armoured engine. By late 1943, the strategic situation had shifted. American P-47 Thunderbolts and P-51 Mustangs were arriving in numbers, both capable of matching or exceeding the 190's performance. The Luftwaffe was increasingly outnumbered, forced to defend against 1,000-bomber raids that saturated German airspace. The 190 remained a formidable fighter, but it was no longer dominant, yet its legacy persisted. The lessons learned from encountering that seemingly indestructible Radial engine influenced fighter design for the remainder of the war and beyond. Soviet engineers studying captured 190s incorporated similar redundancy concepts into late-war fighters. American designers at Republic and Grumman, already working with Radial engines, refined their cooling systems and armour placement based on intelligence about BMW's approach. Even British engineers, traditionally wedded to liquid-cooled inline engines, began experimenting with radial installations for ground attack aircraft. The 190's ultimate evolution came in 1944 with the D model, the so-called Dora, which replaced the BMW Radial with a Junkers Jumo 213 inline engine. The change was driven by high-altitude performance requirements, the need to intercept American bombers flying at 30,000 feet and above. The Dora was faster and climbed better than any A-model 190, but it lost the radial engine's resilience. Pilots reported that the Dora flew beautifully but bled and died like any other inline engine fighter. A single coolant leak, and you were counting minutes until seizure. Some German pilots preferred the Dora's performance. Others missed the A-model's forgiveness. Lieutenant Heinz Lang flew both variants extensively and kept a private comparison in his logbook. The Dora makes you feel like a knight, fast and deadly. The Anton makes you feel like a survivor. Given the choice, in late 1944, when flak and Allied fighters were everywhere, I would have chosen survival. By the war's end, over 20,000 190s had been built, the majority powered by BMW 801 radials in various configurations. They served on every front where the Luftwaffe operated, from the frozen wastes of Russia to the deserts of North Africa, from the invasion beaches of Normandy to the defense of Berlin. They shot down thousands of Allied aircraft. They absorbed countless hits and brought their pilots home. They earned respect from enemies who had initially dismissed them as crude and ungainly. In the decades after the war, aviation historians would debate which was the better fighter, the Spitfire or the Focke-Wulf 190. The arguments generated endless speculation, but pilots who had flown both or fought against both generally agreed on one point. The Spitfire was the more beautiful aircraft, graceful and elegant. The 190 was the more survivable one, built not to inspire but to endure. Wing Commander Hugh Dundas, who flew Spitfires throughout the war and engaged 190s dozens of times, perhaps summarized it best in his memoirs. The Spitfire made you feel like you were dancing with death. The 190 made the Germans feel like they were wrestling with it. Both were effective approaches. But there's something to be said for wrestling. At least you have a chance to walk away. The captured 190 that Armin Faber had inadvertently delivered to RAF Pembrey was eventually struck off charge in September 1943 after extensive testing. It had provided the Allies with invaluable intelligence, not just about German engineering capabilities, but about the philosophy underlying them. That philosophy, prioritizing survival over speed, redundancy over elegance, proved influential far beyond the 190 itself. In post-war years, as aviation technology advanced and jet engines replaced pistons, the lessons of the BMW 801 faded somewhat. Jet engines had no coolant systems to rupture, no separate cylinders to destroy. Damage tolerance became more about structural integrity and control system redundancy than engine resilience. But the underlying principle remained. The best fighter is not necessarily the fastest or most agile, but the one that brings the pilot home. Today, preserved 190s exist in museums around the world. Most are displayed with their cowlings removed. The BMW 801 radials exposed for visitors to examine. People stand before them, studying the cylinder arrangement, the cooling fins, the robust construction. They run their fingers across the metal and try to imagine what it was like to fly behind such an engine, to trust your life to 14 cylinders of air-cooled aluminum, to hear the rough mechanical growl and know that your machine could absorb punishment and keep flying. The butcher bird earned its name through lethality, but it might equally have been called the survivor, because while it killed efficiently, it excelled at something more fundamental, refusing to die. And in war, sometimes the greatest weapon is not the one that destroys the enemy, but the one that denies the enemy the ability to destroy you. The radial engine of the Focke-Wulf 190 was not beautiful. It was not elegant. It was not even particularly efficient. But it was something more important. It was honest. Honest about the realities of combat. Honest about the fragility of human life. Honest about what truly mattered when metal met metal at 400 miles per hour, 6 miles above the Earth. It was engineering as empathy. And perhaps that is the deepest lesson. The machines we build reveal what we value. The Spitfire, with its graceful lines and powerful but delicate engine, revealed British confidence and aesthetic sensibility. The 190, with its blunt nose and nearly indestructible radial, revealed German pragmatism and respect for the pilots who would fly it into harm. Neither approach was wrong. Both produced magnificent fighters. But the 190's radial engine, absorbing 20mm hits that should have been fatal, forced everyone who encountered it to reconsider their assumptions about engineering, about design philosophy, about what truly defined excellence in a weapon of war. And in the end, that reconsideration may have been the 190's greatest contribution. Not the battles it won or the aircraft it destroyed, but the minds it changed. The British pilots who learned to respect brutal efficiency over elegant fragility, the engineers who began designing for survival rather than just performance, the planners who realized that keeping pilots alive to fight another day mattered more than achieving marginal speed advantages. The Butcherbird changed the war, not through any single battle or campaign, but through the gradual, inexorable shift in thinking it provoked. By proving that a fighter could be both deadly and durable, aggressive and survivable, lethal and forgiving. By demonstrating that the best armor wasn't always plate steel wrapped around a cockpit, but 14 cylinders of air-cooled engine that refused to die. The grass has long since grown back over the field near Exeter, where Squadron Leader Matthews first examined that crashed 190 in September 1941. The hedge has been repaired, the scorched earth has healed. But the lesson remains, written in combat reports and engineering diagrams, in pilot memoirs and museum displays, in the design decisions that shaped every fighter aircraft that came after. Some machines teach us through their beauty, others through their function. The Fw190 190 taught through its resilience. And perhaps, in the final analysis, resilience is the most beautiful quality of all. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.